I'd like to do a quick lesson on graphing lines using X and Y intercepts with a little bit more of a focus on this lesson. We can graph a line given an equation, okay? Or we can find the equation of a line given the graph. But what we're going to focus on this lesson is how to draw a line given an equation, okay? We're going to look at the X and Y intercepts of graphs and how to find those. Okay, so what is an X-intercept? An X-intercept is the X coordinate where a graph crosses the X-axis. The X-intercept will intersect the X-axis, okay? It'll intersect the X-axis. So the intercept is where it intersects the X-axis, okay? And the Y-coordinate is where it intersects the Y-axis. So if I look here, the coordinate right here in blue, okay, this is my X-intercept. And notice that there's an X value, but here Y is going to be equal to 0. So if I'm looking at the coordinate, it's some value for X and my Y value is going to be 0. If we're looking at the Y-intercept, in this case, my X value is 0. My X value is 0, but I have some value for Y because I'm on the Y axis. So that's going to be critical when we look for our X and Y intercepts. But the first example, let's do this kind of the archaic way. And I know you would have done this a little bit in grade 9, which is fine. Nothing wrong with that. It's just a different way. If we would have done and used a table of values, okay? So here's a table of values. It says complete the table of values to draw the line of the equation. So I want to complete the table of values to draw the line of the equation. And then I want to do it another way by finding the X and Y intercepts. Okay, so first of all, how would I even complete this table? If I know that X plus Y equals 5, one way is I can just substitute these values in for X and then solve. One thing that I know is I would like to solve for Y in my table. So that's what I'm looking for. What is Y equal to? So in my equation, I would like to isolate Y. So if I want to isolate my Y coordinate, my Y term here, my Y variable, I want to then isolate by moving over my other term on that side. So what I then get is Y is equal to, and when I move over a term, what happens is the sign of that term changes. So that was a positive X, it's going to become minus X. So when I move over that term, we end up with 5 minus X. So now let's substitute in some values. Okay, when X is negative 2, I'm going to get Y equals 5 minus negative 2. And I'm going to get Y equals 5 minus negative 1. Y equals 5 minus 0. I'm just substituting all these values in for X. Okay, Y equals 5 minus 1 and Y equals 5 minus 2. Now, 5 minus a negative 2, we all know our integer rules. We're getting really good at those, I know. So 5 minus negative 2, well, that's 7. 5 minus negative 1, that's 6. And 5, and so on. And you can see right away, actually, after you've done this, as long as there's a pattern with our x's and they're changing by an equal amount. So in this case, this is plus 1, plus 1, plus 1. There will be a pattern with our y values in this linear equation. So this is 7, 6, 5, and we probably wouldn't have even had to have filled in the last couple by hand. We could have seen the pattern. So that takes quite a lot of time. I'm going to go ahead and I'll draw that graph now. So if x is negative, these are of course coordinates, right? This is the coordinate negative 2 comma 7. Coordinates need brackets. They need a comma in between. Negative 2 comma 7 without brackets is not indeed not really a correct way of writing that. So we would need brackets. That's negative 1, 6. We don't have to fill all those in, but I'm just reminding you that really we've got just a set of coordinates. So negative 2, 7 would be up here. I start at my origin, negative 2, 7, negative 1, 6, 0, 5, 1, 4, and 2, 3. Okay, of course, I've got a bunch of points. I'm going to connect those dots. Okay, we only really need a couple of points in order to draw a line, but we've got a whole bunch, right? So another way of doing that, and just a reminder, this is our y-axis and this is our x-axis. Another way of solving drawing this line would be to solve for the x and y intercepts. So I just want to remind us or go through how we would do that. Okay, if I wanted to find the x-intercept, okay, if I want to find the x-intercept, I know that on my x-axis, no matter where I am on this x-axis as I travel along, my y value is 0. Okay, my y value is 0. And I'm going to write that here. Okay, we're going to learn later on that that's actually the equation of the x-axis is y equals 0. And when I'm on the y-axis, my x value is 0 because I haven't moved left or right. I've only moved up or down on the y-axis, right? So my x value on the y-axis is equal to 0. So if I want to find my x-intercept, the interesting thing about that is I know that y equals 0. So we just know that. And if I've got an equation, I'm going to start with that equation, which is x plus y equals 5. And if I know that x plus y equals 5 and y is equal to 0, I'm going to sub in 0 where I see y. So now my equation looks like x plus 0 equals 5. Well, x plus 0 is, of course, x, so x is equal to 5. And I've just found my x-intercept, which is 5, 0. And I can already see it on the graph because, of course, we drew the line already. But another way, instead of filling out the table of values, would have been to find the x-intercept, which is 5, 0. And then let's find the y-intercept. Okay, if I want to find my y-intercept, again, I know that x equals 0. Okay, so I'm going to start with my equation, x plus y equals 5. And where I see x now, I'm going to substitute in a 0. So I've got 0 plus y equals 5. And 0 plus anything is, of course, that thing. So I've got y equals 5. So our coordinate, therefore, would be 0, 5. And there it is right there. And all I really needed was 2 points in order to draw that line. So if you examine here, what's faster? Is it faster to do this down here, find the x-intercept, find the y-intercept, or is it faster to complete a table of values? Well, the table of values is way longer, way more work, 5 equations versus 2, and I think that you can see that this is a way faster method. It doesn't always work perfectly for every type of equation, but for today's equations and practice, it's going to work beautifully. Okay, complete the table of values to draw the line of the equation and then find the x and y intercepts and draw the line. What I'd like you to do is I'd like you to fill in this table of values. I'm going to get you started. I'm going to first of all move over my 3x because I want to isolate y. Okay, so when I do that, the 3x becomes minus 3x, right? When we move something over the equal sign, the sign changes. If that would have been a negative 3x, it would have become positive. But of course it was positive, okay, because there was no sign. So now our new equation here is y equals 12 minus 3x. Okay, I'm going to pause the video. I want you to pause the video rather, and I would like you to fill in the table of values. If you could do that. Okay, so I filled in the table of values, and hopefully you have too. Of course, that was a 12 minus 3 times negative 2, which is going to be a positive 6. So that ends up being 12 plus 6, which is 18. Now, if I wanted to do the same idea, instead of using these coordinates, but find my x and y intercepts, what would those look like? So let's go through that. If I want to find my x-intercept, what do? I let y equal to 0. I set that equal to 0 in my equation. So I'm going to write my equation down. I've got 3x plus y equals 12. So when I substitute in my 0 for y, we get 3x plus 0, and that's all equal to 12. And now 3x plus 0 on my left-hand side of my equation is, of course, 3x. And on my right-hand side, I've got equal to 12, right? The equation, the left-hand side and the right-hand side are divided by the equal sign, right? So I'm going to divide both sides by 3. And when I divide that out, we get x equals to 4. So our x-intercept is 4, 0. I'm going to find that right on my x-axis, right? This is my x-axis, and the equation of the x-axis is y equals 0. Why? Because all along this x-axis, if I go, this is the point -10, 0, right? -8, 0, and so on. Okay, -9, 0. Anywhere along this x-axis, my y value is 0. So that's why that's the equation. Let's find the y-intercept. And when we do that, we know that if I'm on the y-axis, then x is equal to 0. So again, we're going to start with our equation, 3x plus y equals 12. And we're going to sub in, where we see an x, we're going to sub in a 0. So this is 3 times 0 plus y equals 12. And of course, 3 times 0 is 0. What I can do there is I can just kind of cross that off. Goodbye. Okay, 3 times 0 is 0. So we're left with y equals 12. I seem to have frozen here. Hold on. Excuse me. Y equals 12. And of course, our coordinate there would be 0, 12. And I know my y-axis is up here, and we only go up to 10, so we're going to have to sort of add on a couple of points here. There's my y-axis, and all along the y-axis, x is equal to 0. So I'm going to add 2 more little values here. Here's my y-intercept of 0, 12. So this is 0, 12, and this one down here was 4, 0. Okay, and now how would we draw those lines? We only really need 2 points to draw a line. Okay, and there we go. There's our line. Much faster than the table of values. Now the table of values still has its uses, and it is good practice. Let's look at the next one, and let's just maybe skip that. Okay, we know it's archaic. So I'm going to give you a quick opportunity to try this one. Or actually, there's a few tries down here. So why don't we do this last one together? We'll find our x-intercepts one more time. This is a bit different because there's a 0 over here. Now, sometimes students forget there's always got to be something on both sides of the equation. We never just leave that blank. Sometimes I see in math where I'll see students solving and they'll just have like 3x plus 15 equals, and they'll just leave that blank. Yikes! Now, we always, if there's nothing over there, we have to put in a 0. Okay, just as a little aside. So here we've got 0. That's kind of weird, isn't it? But that's okay. Let's find our x-intercept and our y-intercept, okay? So if I want to find my x-intercept, I know that y is equal to 0. So I'm going to take my equation, 3x minus 5y minus 15. And where I see y, I'm going to sub in a 0. So, so now I've got my 3x minus 5 times 0 minus 15 equals 0. Now 5 times 0, I'm just going to ignore that. Let's cross him off. He's gone. 5 times 0 is 0, so we can just say bye-bye. Okay, now this is a 3x. We're left with our 3x. And a minus 15 equals to 0. Now if I want to solve for x, I need to isolate my 3x, right? We're going to get him by himself. I'm going to move over the minus 15. And when I move him over, we end up with a plus 15. So our next line should look like 3x equals 15. And we divide both sides by 3. and x is equal to 5. So our x coordinate here is 5, 0. And our y coordinate, or our y-intercept rather, we know that x is equal to 0. We're going to start with that same equation. We've got our 3x minus 5y minus 15 equals 0. So if x is 0, we're going to plug in our 3 times 0, and that's minus 5y minus 15 equals 0. 3 times 0 is, of course, 0, so that guy's gone. And we're left with a negative 5y minus 15 equals 0. And again, let's go isolate the 5y, the negative 5y. We have to get that term by itself. We're solving for y, so we're isolating that one. And our next row will look like negative 5y equals 15. Divide both sides by negative 5. And we get a y equals negative 3. So our coordinate here, x was 0, y is negative 3. And just to note about the algebra, I know we've done some in class. The reason I move things over is because when you get into higher levels, you can work down as you did in junior high. I'm sure most of you probably learned you would, add 15 or move working down. You can do that method, but sometimes when you get into higher levels, you get so many terms. We'll have equations where we have 5 and 6 and 8 terms. So it gets very busy if you're working down. So it's less cumbersome to just move things over the equal sign, okay, and change that sign. So of course, when you're starting out, there's different methods. Now we're sort of changing a little bit in high school. Same idea. If you want to work down, though, it's not the end of the world. So there's my x-intercept, which is at 5, 0. And here's my y-intercept, which is 0, negative 3. And of course, right, this is my x-axis. And the equation of my x-axis is y equals 0. And here's my y-axis. And the equation of my y-axis is x equals 0. And now I draw a line through those two values. Okay, I've got 3 tries below. I'm going to, sorry, I may have gone over that really quickly. You might have to pause that. If we go down, there are 3 examples just using x and y intercepts I'd like you to try. So I'd like you to pause the video and try those 3 examples, and let's see how you do there. Okay, so hopefully you were able to get these answers. The very first one, x is 9 and y was 2. And the next one here, x was 12 and y was 4. And the third one, x was negative 4 and y was 5. So given that those were done, hopefully those weren't too bad for you. I would like you to do the assignment, that is the assessment it'll be on Google Classroom, on x and y intercepts. And as usual, if there are any questions whatsoever, please do not hesitate to contact me or your teacher. Thank you.